Hey guys, today we're looking at modeling data with functions. We're looking at exponential functions and then power functions as well. This is going to be pretty graphing calculator heavy, so if you don't have a graphing calculator, you can try to do the same with Desmos. But if you're having trouble, you may just need to wait and come and borrow a graphing calculator from me to be able to go through these notes. So, exponential functions we know look like a times b to the x power. So if we are given 2 points, but we don't know a or b, we then can solve and find a and b. So we just plug in our x and our y values. So in this case I have y is 0.0625 is equal to a times b to the -1. And then I have 32 is equal to a times b squared. One thing we can do is we can divide these out. So I'm actually going to flip these around. I'm going to put 32 equals ab squared divide by 0.0625 is equal to a b to the -1. So when I do that, my a's will cancel, and I get 32 divided by 0.0625 happens to be 512. And then I get b to the second divided by b to the -1. So since I'm dividing, I'm subtracting those exponents, so 2 minus a -1 is b to the third. Well, that I can solve because I can take the cube root of both sides. So the cube root of b to the third is just b. The cube root of 512 is 8. So b equals 8. Then I can use either one of my functions, but I'm going to go back to this 32 equals a times 8 squared. So then I have 32 equals 64a divided by 64 on both sides. So a reduces then to 1/2. So then we want to go back and write this exponential without our y's and x's. We want just a's and b's. So y equals 1/2 times 8 to the x. There's our exponential function. So all of that was done without a graphing calculator. But how do you know when you're dealing with exponentials? Well, if when we plug into the graphing calculator, we switch our y values to the natural log of y, and it's linear. So this next slide walks you step by step through how to do that. So here's a list of data. You're going to type this x value into L1. You're going to type the y value into L2 under your stats. So stat, edit, go and type those into L1 and L2. Then go over and all the way up to L3, and where it says L3, you're going to type the natural log of L2. And L2, to get there, you're going to hit second and the number 2. Stat plot, change your y list to L3, and stat plot is second y equals. So you'll go into stat plot, change the y list to L3, then you'll hit graph, and you'll want to hit zoom stat. And you should notice then that x and the natural log of y is linear. It should form a straight line there. So then find the equation with 114 and 228. Well, we could go practice again with the method that we just did, and if you want to, you can go and do that. The other thing we can do is called exponential regression. So with exponential regression, we can use all of the original points, or we can plug in to just a few points. But with exponential regression, since we already have all of those typed in, go ahead and put those, go into stat, over to calc, and then exponential regression, and you should get 7 times 2 to the x as your answer. If you want to try it with just these two, I'll go through that now. If you feel confident on it, you can go ahead and fast forward. So remember that we're looking at y equals ab to the x power. So I'm going to put, and I'm going to start with my bigger point first. 28 equals a times b to the second. 14 equals a times b to the first. And I'm going to divide these. So 28 divided by 14 is 2. A divided by a cancels. B squared divided by b to the first is b. So I get 2 equals b. And then I need to plug that back in. So I'm going to use 14 equals a times 2 to the first. So 2 to the first is 2. I'm going to divide by 2. 7 equals a. So then y equals 7 times 2 to the x power. We got the same thing using exponential regression and with those points. All right, a power function switches that x and b value. So this time we have y equals a times x to the b. So here we can plug in 12 equals a times 9 to the b, and then we have 8 equals a times 3 to the b. I'm going to go ahead and divide those as well. So 12 divided by 8 is 3 over 2. They both divide by 4 is equal to the a's cancel. And then I have 9 over 3 to the b. Well, 9 divided by 3 does reduce, so I have 3 halves equals 3 to the b power. Since they're both raised to the b power, I can divide those and simplify. So from there, we're going to have to go into logs. So I have the log of 3 halves base 3 is equal to b when I switch that around. So probably going to need to use change of base, and you can write this as log of 1.5 if you want. Plug that in, you should get b is approximately 2.71. From there, we're going to plug back in, and so I'm going to use my smaller values here. So 8 equals a times 3 to the 2.71. I'm going to go ahead and divide out 3 to the 2.71 and just type that all in at once. So a is approximately 0.41. So then I have y equals 0.41 is my a, x to the 2.71 power. All right, but if it doesn't tell us that it's a power function, how do we know? The rule here is if the natural log of x and the natural log of y is linear. So we're going to do the same kind of thing, except we need to take the natural log of both. So here's some values here for, I'm not sure what we're referring to, but talking about planets. Earth is at 1, and we have some x, y values that are comparative with different planets. So we're going to go in and we're going to go into stat edit. We're going to type our x values into L1. We're going to type our y values into L2. Then, just like we did before, go over to L3 and up to that header, and you're going to type the natural log, but this time you're going to put the natural log of L1. And then you're going to go over to L4 and do the natural log of L2. So then when you go into stat plot, we're going to change the X list to L3 and the Y list to L4. Graph, zoom stat. If it's linear, then we can pick 2 points, solve for A and B, like we talked about with exponential regression or with the exponential function, or we can use what's called power regression on the graphing calculator, just like we were able to use exponential regression with the exponential function. So if you use power regression, you will get y equals 1x to the 1.5 power. So if you want to practice going through another power function by hand, we can do that. I'm not going to use these points to solve for anything with the pick 2 points and solve, but I will definitely go over another one with you if you'd like. All right, rewriting log equations by solving for y. So we want to get y by itself and then have everything else alone. So the first thing I need to do though is get all of my logs to the same side here so that I can combine them and then try to get rid of the log that's with the y. I can't just get rid of log by dividing it out or something. So when I move this over, I'm subtracting it. So I'm going to subtract, I have log of y, and I have minus, and I have that 0.2 log of x, but I'm going to go ahead and put log of x raised to the 0.2 power. You can do that in 2 steps if you want. That equals 0.8. So now that those are subtracted, they have the same base, I can rewrite this with 1 log, and then I have y divided by, since it's subtracted, x to the 0.2 is equal to 0.8. Now that I have that, I can rewrite this using exponentials. So my base here, since it's not written, is base 10. So I have 10 to the 0.8 is equal to y divided by x to the 0.2. So then I can multiply both sides by x to the 0.2 and y is by itself. So I get y equals 10 to the 0.8 x to the 0.2. But that 10 to the 0.8 I can go ahead and multiply out, so I can get y is equal to 6.31 x to the 0.2. That looks like our power function that we just used. All right, and then b. So I only have 1 log here, so I can go ahead and start to try to get rid of that log. Well, I have a log base 10, so I can then raise everything to the 10th power. So I have 10 to the negative 0.12 plus 0.88x equals y, and I can put that y equals on the other side. So then, since both of those are raised up, I can separate them. So I have 10 to the negative 0.12 and 10 to the 0.88x. I can separate those out and take those individually to the powers is equal to y. 10 to the negative 0.12, I'm going to go ahead and put my y equals, is about 0.759. And then 10 to the 0.88 is 7.586. And then I still have that raised to the x. So there's my answer there. That's an exponential that you see. All right, that's all I have on solving today. So if you have questions, come in and see me. Otherwise, I'll see you in class.